So in this video, I will solve the questions which is less which was pending due to some technical reason. I couldn't it wasn't fulfilled to continue to solve the problems of this. Okay, so now it is the second part. So here you can see that h by 4 pi rl into j plus of 1. Okay, so after that the energy distance between two rotational level energy distance between two rotational level, okay, usually expressed as centimeters inverse, okay. So the wave number corresponding to the to a del a del e is given by basically del is given by u is equal to del of e divided by hc, okay, in unit centimeter inverse. So the energy level in centimeter inverse before, so the energy before for the centimeter inverse are therefore u of j is equal to b into j plus of 1, where b is equal to h divided by 8 pi square lc. Okay, lc, the rotational energy level of diatomic molecule. So the rotational energy level for the diatomic molecule what will be? So it will be, wait, it will be this I could go with and another last one. Okay, so this is 0, this is 2b, this is 6b, and this is 12b, and this is 30b. Okay, sorry, 20b. Rotational energy as of a rigid dynamic molecule and allowed transition. So this is what this is rotational energy molecule rotational energy level of residue dynamic residue dynamic molecule and allowed transition. Molecule and allowed transition. Okay, so the selection rule for rotational transition is del of j is equal to plus minus 1. So this is a selection rule for rotational uh, rotational transition. Okay, rotational transition. So in addition of this requirement, the molecule of has to be process of dipole moment. So as the dipole moment rates, the rotating dipole moment consecutive of transitions dipole operator nu. So consecutive of dipole operator nu and molecules such as that HCl, HCl and CO, cobalt oxide will slow the rotational spectra, while that hydrogen and chlorine and carbon dioxide will not. Okay, so the will not, and the rotational spectra will appear as follows. So the rotational spectra, so the rotational spectra will allows as follow. Okay, as follows of, let's say this is uh, this is uh, this is 2b, and this is 4b, this is 6b, this is 8b, this is 10b, and this is 12b. Rotational spectrum of rigid dynamics. Okay, so rigid dynamics will be that. So vibrational and rotational of diametric, let's say this is a heading, that vibrational and rotational of a diametric, what will be rotational, vibrational, diametric will be, we know that simple pendulum or stretched strings exhibit the simple harmonic motion about the equilibrium position. So molecule also be so the quantized vibration energies, the quantized vibrational energies, quantized vibrational energies, what will be E0 will be E0 of the harmonic oscillator, harmonic oscillator R, or what E0 divided by nu plus of half. Okay, so H nu, so U is equal to 0 1 2 dot dot dot. So this is the vibrational frequency nu R, the vibrational frequency nu R is related to the force constant K n, the force constant K through so V of R is equal to 1 by divided by 2 pi. Okay, root over of K by nu hertz. Okay, so the vibrational motion occurs under the action of binding potential energy. So the vibrational motion occurs under the action of binding action of binding potential energy, binding potential energy. So this is the here is end. So the question was said that question, what a question asks? Question asks that obtained that the frequency of newer spectral of lines. So definitely I obtained in there in this solution. And after they said that molecule characteristics and its momentum. Okay, so that's the main question was. Now come to the point. Second question. Second question what? Second question said that sorry, 1 minute. Second question said that outline B. Outline elementary theory of nuclear magnetic resonance. Elementary theory of nuclear magnetic resonance. In nuclear magnetic resonance, NMR. ঠিক আছে, and discuss its application. Discuss its application. So what will be the application? What is the NMR? So professionally I have to solve this question. What is NMR? So nuclear magnetic resonance, it is basically very good point and very good answer. So nuclear magnetic resonance spectroscopy is non let's say start first first topic is point is nuclear magnetic resonance. Nuclear magnetic resonance. What will be? So nuclear magnetic resonance and spectroscopy is a non-destructive analytical is a destructive analytical technique, okay, that is used to prove the nature, that is used to prove the nature, that is used to prove the nature and characteristics okay, that is used to nature prove characteristics of molecular structure of molecular spectra. ঠিক আছে, molecular spectra. A simple NMR in a nuclear magnetic resonance experiment produced information in the form of a spectrum. Information in the form of a spectrum. Okay, so in the form of a spectrum, a simple harmonic oscillator which is to provide details about number one, the type of atoms present in simple. So the type of atom present in the sample present in the sample. Okay, and number point two, second point is the relative amount of atom, the relative amount of atom present in the sample, okay, present in the sample. So third number is basically the specific environment. So the specific specific environment of atom within a molecule basically. And fourth point is the purity and composition of sample. The purity and composition of sample sample. Okay, so structural information about the molecule. Fifth number is that structural information about a molecule, about a molecule. Okay, so including constitutional and conformational isomerase. Okay, including constitutional and conformational isomerism. ঠিক আছে, so that's the there are a number of important characteristics of NMR spectroscopy, which is makes that the favorable to a wide array of industrial and commercial research. So there are NMR spectroscopy, NMR spectroscopy, which makes favorable wide array makes favorable wide array, okay, of industrial and commercial research, industrial and commercial research. Okay, so first, so for which type of industrial and commercial research, first number one, there are many which are AMR active. So there are many which are NMR active. Okay, which NMR active, some of the more common NMR active, some of the more common NMR, ঠিক আছে, NMR active. Okay, some of the more common NMR active, more common NMR active nuclei include 1H, include 2H, include 13C, include 11B, include 15N. Okay, include 19F and 31P and 195 PT. Okay, so NMR spectroscopy is generally, number two point is NMR spectroscopy is generally a non-destructive technique, is a non-destructive technique, meaning that samples can be recovered, meanings that samples can be recovered. Okay, meanings that samples can be recovered. And number 3 point is only a small quantity of material is required. Only a small quantity of material is required. Okay, material is required. um, hmm, Clear. Material is required. Okay, like two to like 5 to 20 milligram. Okay, and for 4 point মানে simple preparation is simple and minimal. Simple preparation is simple and minimal. Okay, simple preparation minimal. Typically samples are simply dissolved, and typically samples are samples are dissolved. Okay, so typical samples are simply dissolved. Simply dissolved. Okay, simply dissolved. That's the things. Okay, and dissolved in an appropriate solvent. In an appropriate solvent. Okay, so this is the things. Application of NMR spectroscopy. So NMR spectroscopy is a technique used by most modern chemical laboratories, and it has a application of wide range of discipline and মানে development of new methods of NMR. So is an active area of research, and method of NMR spectroscopy have particular relevance of following disciplines. Okay, so chemical research and development organization, development or organic or inorganic chemistry. Okay, so this is the chemistry field, and so of NMR, yani nuclear magnetic, sorry, NMR, yani nuclear magnetic resonance. So this is the application. So first application is মানে so this technique used by most modern chemical laboratories, used by most modern chemical laboratories, chemical laboratories. Okay, most modern chemical laboratories like uh, most modern chemical, and it has application of wide range of discipline, and it has application to wide range uh, of discipline, wide range of discipline. Okay, and development of new applied method, and development of new method. Okay, development of new method. That's the things. Okay, development of new method, and for NMR spectroscopy. So first point is chemical chemical research and development, chemical research and development, um, organic and inorganic and physical chemistry, organic, inorganic and physical chemistry. Okay, and point number 2 is chemical manufacturing industry. Manufacturing industry. Okay. Point number 3 is biomedical and biochemical research. Biomedical and chemical, biomedical and biochemical research. Okay, and 10 number is the food industry. Okay, and 5 number point is a geographical development and production. Geographical development and and production. Okay, and 5th point is polymer industry. Polymer industry. Polymer industry. Okay, so common application of NMR is the structure, also quality assurance and quality control. For nuclear magnetic resonance is also it is also used for QC, yani quality control department, and also it also that the simple purity of simple purity determination. It use also simple purity determination. Okay, so that's the main entire thing. Okay, and okay, and now question number 5. I'm going to solve selection B. So it is over. So it is selection B. Sorry, section B. Section B. So what will be the section B? Section B 5A. 5A number question. In a nuclear fusion process, in a nuclear fusion process, মানে 4 hydrogen nuclei combine to form 4 helium nucleus. Obtain the energy released in such a process. Yeah. Such a process if the same process is responsible. If the same process is responsible for energy of a star of mass of of energy of star of mass energy of a star of mass 2 into 10 to the power 30, 2 into 10 to the power 30 kg. Okay, each kilogram each gram having each kilogram having 6 into 10 to the power 26 protons. Okay, 20 proton. What could be magnetic of energy released? What could be magnetic of energy released? What could be the magnetic of energy released? So released in it. So what could be the magnetic of energy released? So this is the question. The question asked that 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 the ultimate theory. Okay. So the value, this is very much, this is Wait a minute. So in this question, the value, so as per the question, the value value can be calculated from the mass of the product and tens of equation. It's okay. 14 and 7 plus 4 helium uh, atom, that's and 0 8 17 plus of 1 hydrogen 1. Okay, so the exact mass of exact mass of the 14 and 7 is equal to 14.0031. We know that on an atomic mass unit, we already know that. And for for helium helium 2 is equal to 4.0026 atomic AMU, atomic mass unit. And for 17 oxygen 6, it will be around 16.99. So this is 17. And for hydrogen 1 H1, it will mass atomic mass 1.0078 around AMU, any atomic mass unit. So the sum of the masses, so sum of masses of rectants 14.0031 plus 40026 is equal to, definitely what it will be, 8.0057 AMU, atomic mass unit. Sum of the masses of product, sum of the masses of product, what it will be, sum of the masses of product. So sum of the masses of product will be definitely solo 16.99 plus of 1.00, so it will be around 17.99, mane around 18. Okay, so this will be the mass. Therefore del m is equal to mass class product. So del m will be mass class product. Okay, so del s will be for mass class product, different and mass sum of masses of rectants, sum of masses of rectants. Okay, masses of rectants, and it will be around 18.00 minus of 18.0069 minus of 18.0057 is equal to, what will be the come out? So it will be around positive 0.002 AMU in atomic mass unit. As the above reaction involves increase of the 0.22 AMU, so as the above reaction involves 0.02 atomic mass unit, therefore the equivalent energy will be being absorbed. Okay, so therefore the equivalent energy will be absorbed. Okay, so therefore the value of Q will be negative. So Q's value will be negative. Okay, negative. And as the reaction of androgic. Okay, so 1 AMU is equal to basically what, basically 931 MeV per A dot M dot U. Okay. So it will be q will be around minus 0.002 into 931, so it will be around minus 1.862 mega electron volt MeV. This is the ultimate answer of first reaction. Okay, as per the questions of first reaction is sorry, I did a little more mistake here. Okay, so above thing is okay, let come to the point of second questions. Okay, so second questions is basically you have to obedient for the questions number 2. Second questions. So B, obtain the Q value for the following four nuclear, obtain the Q value for the following four nuclear reaction, for the following four nuclear reaction, reactions number 1. What is the number 1 is 14 and 7 plus of helium of basically 4 or 2. It will be turned around oxygen 7 8 plus of hydrogen 1 1 first. And second, I have to prove that lithium 7 3 plus of helium of 2 4 is equal to B10 10 5 plus of neutron 0 1, and 3 will be lithium of 3 6 plus of hydrogen of 1 1. Okay, helium of 2 3 plus of helium of 2 4 IV, maybe of sodium of 11 23 plus of hydrogen of 1 1 plus my transition into sodium neon 10 20 plus of helium 2 4. This is the questions number first. And nuclear reactions, obtain that the Q value. To find out, I have to find out that the Q value of these equations. Okay, so let's start one by one to find out the Q value. So so one value is already I find out here. Okay, here in this section, and now the second value will be second answer. So second answer will be what? Let's see. Second answer of this, they are given that lithium 7. Okay, so as per the questions, lithium 3 7 plus of helium 24, helium 24 is struck into B510, okay, and plus of 1 0 and 0 is equal to 7.01 AMU in atomic mass unit. So the exact mass of the exact mass of lithium, mass of 7 lithium 3 is equal to 7.016 AMU atomic mass unit. So number of the mass of helium hydrogen, also sorry, helium 24, it also around 4, and for boron 510, it's also 10.81, okay, atomic mass unit, and 1 and 0, it will be around 1.0086 AME. So sum of masses of reaction, so the sum of masses reaction, okay, sum of masses of reaction is basically 7.016 plus of 4.0, 4.0, okay, 4.0, so it will be around 11.01, okay, 11.01 AMU atomic mass unit. Sum of the masses, so sum of masses of products, okay, so sum of masses of products is basically what will be 10.81 plus of 1.00 is equal to 11.81 AMU, okay, and del of m is equal to 11.81 minus 11.01, it will be around 0.80 atomic mass unit AMU, okay, and for q is equal to what? Q is equal to minus of 0.801 into 931, so it will be the value of minus of 745.7 mega electron volt. Clear? So the reaction of endoorganic and the energy being absorbed, so this reaction energy will be absorbed, okay, so in this energy, the energy will be absorbed, so absorber energy will be happen, okay, in this. And then second reaction number 3, third number reaction said that lithium 3 of 6 plus of 1 hydrogen 1, basically helium 2 3 plus helium 2 4. This is one of the toughest questions from the UPSC, because you have to remember all the elements exact figure. So exact, without you cannot solve it, okay, properly. If you don't know, then definitely you cannot, okay. So here you can see that the lithium 6 of lithium 3, its atomic 6.01 0151 a atomic mass unit, okay, and 1 hydrogen 1, it will be that 1.0078 atomic mass unit. ঠিক আছে, and for 3 helium 2 it will be around 3.0160 AMU, and for 4 helium 2 it will be around 4.0026 AMU. Okay, so the sum of masses of reactants. So the sum of sorry so the sum of masses of reactant, ঠিক আছে, sum of masses of reactants will be what? Sum of masses of reactants will be uh, sorry will be around 6.0151 into into plus 1.0078. It will be 7.022 atomic mass unit. Okay, and sum of the massless product, sum of the masses product, 3.0160 plus 4.0026, it will be around 7.0186 AMU. So del m will be what? 7.0186 minus of 702 মানে 7.0229. Okay, so it will be around a minus of 0.0043 atomic mass unit. So q will be 0.0013 into 931 or this, so it will be mega electron volt its unit. So what will be its unit? Maybe per atomic mass unit. Okay, so it will be around 4.003 mega electron volt. And for the question number 4 said, what said? Question number 4 is this: that sodium 3 and something change hydrogen, both two particles are combined forming here. So 23rd sodium of 11 plus of 1 hydrogen 1 is equal to 20 neon of 10 plus of 4 helium of 2. Okay, so exert of 23 and 11 will be, the atomic mass unit will be 22.9897 atomic mass unit, and 1 hydrogen of 1 will be that 1.0078 AMU. Okay, and for 20 hydrogen plus 10 it will be that 20.1797 AMU. Okay, and for 4 AM2 it will be around 4.0026 A.M.U. Sum of the masses of reactants, sum of the masses of reactants is equal to 22.9897 plus 1.0078. It will be around 23.9975 AMU atomic mass unit. So sum of the masses of product, so sum of the masses of product, sum of the masses of product, what it will be 20.1797 plus of 40, sorry, 4.0026, it will be around 24.1823. So del m will be what? Del m will be 24.18 minus 23.99, so it will be around 0.18 atomic mass unit. Okay, so q will be what? So q will be 0.18 minus of sorry into 931, so it will be around minus of 172.04 atomic mass unit. This will be the answer. And I took a little more mistakes in there, so I'm going to rectify it. That question number first said that in the fusion process, nuclear fusion process, question number 5a, said that in a nuclear fusion, so I'm going to copy and okay from there. Wait. Okay, this is the question. I'm taking little more water. So answer will be what? No, when hydrogen, four hydrogen atom lows make to the one hydrogen atom nucleus, a small amount of matter seems to disappear. No, when four hydrogen nuclei, uh, fuse um, to make one helium nuclei. Okay, মানে one helium nucleus, a small amount of matter seems to disappear. Small amount of matter seems disappear. Okay, a small amount of matter seems to disappear. So four hydrogen nuclei is equal to what? So four hydrogen nuclei is equal to 6 into 6.693 into 10 to the power minus 27 kg. Okay, and one helium nuclei, one helium nuclei is equal to 6.645 into 10 to the power minus 27 kg. So difference of masses. So the difference of masses will be what? So the difference of masses will be definitely 0.048 into 10 to the power minus 27 kg. Okay, 27 kg. So the mass is connected to energy according to the Einstein equation. So mass is connected to the energy. Okay, according to Einstein equations. Okay, so E is equal to mc square. Okay, so mc square is basically 0.048 into 10 to the power minus 27 into 3 into 10 to the power 8 meter per second square. Okay, so it will be around 0.43 into 10 to the power 11 joule. So recall that 1 joule is equal to basically um, roughly equal to the energy of the apply falling into the table of to the follower. So it 1 joule it is equal to the energy. Okay, it is clear. So question number 14 is also clear here.